Hey guys, Mr. Gomes here. So today we are going to learn about the two basic types of covalent bonds. Now, if you remember, covalent bonds are bonds in which electrons are being shared between atoms. But not every atom will share electrons the same way. And we're going to learn about the two basic types here today. Okay? So what I have here is I have some ring stands with rubber bands, paper clips, and styrofoam balls. Okay? And the ring stands are representing nuclei or a nucleus of different elements. Okay, so here I have two fluorine atoms, so these are the nuclei. And then the rubber band is the electronegativity of the atom. So the electronegativity, if you remember, is the atom's ability to attract electrons in a bond. So how greedy is that atom for the electrons? That's the electronegativity. Okay. So because both of these are fluorine atoms, they have the same exact electronegativity, which means they're going to pull equally at those electrons, and they are going to share those electrons evenly. Okay? So here you have fluorine sharing the electrons evenly. Nothing too special about that. But now we're going to talk about what happens here with oxygen and hydrogen. If you look carefully here, you can see that oxygen has two rubber bands, and the hydrogen has one rubber band. So the way why I set it up like that is because oxygen is more electronegative than hydrogen, which means oxygen is a lot more greedy for electrons than hydrogen is. Okay? So when they share electrons, here's what's going to happen. So I've got some textbooks here to make sure that nothing falls apart while I'm trying to record this and everything stays put like it should. So here, about here is the middle, okay, of the bond or the space here between these two nuclei. And as you can see, hydrogen still sort of has a grip on these electrons, but they are definitely closer to oxygen, okay? So what ends up happening here is we get something called polarity, okay, where the oxygen is going to be partially negative. So it does not have a complete negative charge because it has not taken the electrons from hydrogen. Okay, hydrogen still has a grip on those. So oxygen is partially negative, and then hydrogen is going to be partially positive. Okay, because it's sort of losing the electrons, but it's still kind of like trying to hold on. Okay, so because we have these kind of opposite sides that are kind of opposite but not completely opposite, we call this a polar bond. We call this a polar bond. Okay, so a polar bond is kind of like North Pole, South Pole, opposite sides. We have a partially negative here portion and a partially positive portion of this bond. Okay, over here when we had the fluorines where everything was even all throughout, this was a non-polar bond. Okay, this is a non-polar bond. Now, O and H make up water, right? Water is H2O. So as you can imagine, water is a polar molecule because it's got two polar bonds that are asymmetrical to each other. So things that are polar, like water, will dissolve in water. Okay, so it's the principle of like dissolves like. So I can dissolve something in a substance if that something is like the substance. Okay, they have to be similar to each other. So things that are polar dissolve in water because water is polar. Okay, so the word polar in chemistry is essentially kind of synonymous to the word hydrophilic in biology. So if you remember from biology, hydrophilic means things that like or love water. Well, those are polar things. Okay, and this is why those things like water. Now, things that don't like water, like oil, you know how oil and water don't mix? It's not because of density. It is because oil is hydrophobic. Oil is nonpolar. Nonpolar covalent and polar covalent, they don't mix because this has partial and negative charges and it wants to mix with other things that have partial and negative charges. This is nonpolar. It has no charge. It is completely even all throughout. It's only going to mix with things that are totally even all throughout. Okay? So that's our little demo there for polar and nonpolar covalent bonds.